close your eyes for a moment. Picture a time long before cities, before oceans separated lands, before there were even the continents you know today. The world was one, a single vast stretch of land called Pangea. One supercontinent surrounded by one endless ocean. No borders, no nations, only Earth, whole and alive. The air was warm. The skies were wide. Rivers wound through forests of ancient trees. The sound of the wind echoed across open plains that stretched for thousands of kilometers. Somewhere far away, volcanoes glowed red against the horizon. The world was restless, yet peaceful in its own way. During this time, life was simple but strong. Reptiles ruled the land. Early plants covered the ground. Giant insects buzzed through the heavy air. The climate was strange, hot, dry in the center, and wet near the coasts. Deserts larger than anything you've ever seen touched forests that reached the sea. The earth was young, full of movement, full of sound. As you listen tonight, we'll travel back to that ancient world. You'll hear how the land formed, how the winds blew, and how everything, mountains, rivers, even the air itself, worked together in balance. You'll feel the rhythm of a planet still building its shape. So, take a deep breath. Let the noise of today fade away. Let your mind rest in the calm of deep time. This is the story of Pangea, the world when Earth was one. Over 300 million years ago, Earth's continents were not separate like today. They were slowly moving, inch by inch, toward one another. This movement was not sudden. It took millions of years. Under the surface, Earth's crust shifted and folded. Massive slabs of rock, called tectonic plates, pushed together. Over time, every continent joined into one large supercontinent. This landmass is known as Pangea. The world during that time looked simple but strange. The ocean covered most of the planet. One single sea, called Panthalassa, surrounded the supercontinent. Smaller inland seas formed between the folds of land. If you were standing on Pangea, you could travel thousands of kilometers without reaching an ocean shore. The land stretched across the equator and into both hemispheres. From space, the planet would have looked like one giant brown-green mass surrounded by blue. The climate of Pangea was different from modern Earth. The shape of the supercontinent changed how winds and rain moved. Moisture from the oceans had to travel long distances to reach the center. The middle of Pangea was dry. Deserts stretched endlessly. Sand and rock covered the land. Temperatures rose high during the day and dropped sharply at night. There were no vast fields of grass or flowers. The land was bare in many regions, filled with dust and sparse vegetation. Only the hardiest plants could survive there. Closer to the coasts, the air was humid. Rain fell often near the edges of Pangea. Rivers and lakes filled with warm water. Ferns and early trees grew near these areas. Swamps formed where water collected. Large forests of primitive plants appeared, especially along the tropical zones. The air smelled of wet earth and resin. You would have seen thick clouds forming above the forests, bringing brief storms and heavy rainfall. The Earth's atmosphere had more carbon dioxide than today. This made the climate warmer. The average global temperature was higher, and the poles had no permanent ice. Even the northern and southern tips of Pangea had forests and seasonal vegetation. No glaciers existed. The air pressure was different too. Oxygen levels were slightly lower. If you tried to breathe in that world, you would feel the air thick but less rich. Animals adapted to those conditions over time. Reptiles, in particular, thrived. Their lungs were efficient, and they needed less oxygen to survive. The land on Pangea was divided into regions with unique climates. The western part was dry and mountainous. Central Pangea was an endless desert. The eastern coasts had rivers, forests, and wetlands. Volcanoes were active along the edges where tectonic plates met. You would have seen smoke rising from the distance. Earthquakes were common, shaking the land as plates collided and pulled apart. New mountains formed slowly, their peaks eroded by wind and rain. Life during this time was spreading across both land and sea. The oceans were full of marine reptiles, fish, and invertebrates. Coral reefs were less common because the oceans were warm and sometimes too acidic for coral to grow. On land, amphibians and reptiles dominated. The first dinosaurs were beginning to evolve. They were small, fast, and adapted to the dry conditions. Insects buzzed through the forests. Some grew large because of the warm climate and thick air. There were no mammals like today, but their small ancestors existed, tiny, shrew-like creatures hiding in shadows, feeding on insects and plants. The plants on Pangea were different too. There were no flowering plants yet. No grass covered the land. Instead, ferns, cycads, and conifers were everywhere. These plants reproduced using spores or cones. They formed dense forests along rivers and lakes. Some trees grew tall with thick trunks and needle-like leaves. The air carried a constant earthy scent mixed with the aroma of sap. Decomposing plants enriched the soil, creating dark, fertile patches near water sources. These areas supported diverse life. As the sun moved across the sky, the landscape changed color. The mornings were cool, with a thin mist over lakes and swamps. The afternoons were hot, dry, and bright. Winds blew sand and dust across open deserts. Nights were silent except for the sounds of insects and the distant rumble of volcanoes. Lightning storms sometimes flashed across the horizon, lighting up the plains for moments before fading again. Pangea was not a peaceful world. The forces beneath the crust were strong. Lava flowed through cracks in the land. Ash clouds darkened the sky at times. These eruptions shaped the future continents. The molten rock cooled into new landforms. Mountains rose, rivers changed course, and lakes formed in deep craters. These processes happened slowly, over millions of years, but they defined the future map of the Earth. The supercontinent was temporary. The same forces that brought it together would eventually tear it apart. But during its existence, Pangea changed how life evolved. The connected land allowed species to move freely from one region to another. Reptiles spread across vast territories. Early dinosaurs migrated through open plains and deserts. The seas surrounding Pangea hosted creatures that adapted to warm, shallow waters near the coast. This movement of life set the foundation for future ecosystems. Pangea also affected the flow of ocean currents. With one massive ocean, heat distribution around the planet was uneven. The equator remained warm, while the poles stayed cooler but not frozen. Ocean currents moved slowly, influencing the climate on land. Areas near the coasts were more stable, while the interior regions faced harsh extremes. Rain was rare in the central deserts, and when it came, it brought sudden floods. Rivers cut deep channels through dry plains, leaving behind traces that scientists study today in fossilized rock formations. Over time, sediment built up across the landscape. These layers preserve the remains of ancient plants and animals. Fossils found in Africa, South America, and North America show the same species, proving that these continents were once connected. The evidence of Pangea lies in rocks, fossils, and magnetic patterns frozen in the crust. They tell the story of a single massive landmass that once ruled Earth's surface. If you were to walk on Pangea, you would experience extremes. One day, you might cross a humid forest full of ferns. The next, you would step into a dry plain under a scorching sun. The sound of wind would fill your ears. Insects would hum nearby. Reptiles would bask on rocks. You would feel the ground tremble from deep movements below. The horizon would stretch endlessly, with no sign of modern life, no cities, no birds, no flowers. Only the raw face of an early Earth. This was a planet still forming its balance. The forces of nature shaped every part of it. Water, wind, and fire carved the land, while life adapted to every change. The air, the heat, the pressure, all were part of an ancient rhythm that continued for millions of years. Pangea was a moment in that rhythm, a chapter in Earth's long story, written in rock and time. The life that existed during Pangea was shaped by the planet's heat, dryness, and limited water movement. The massive size of the continent changed how air and ocean currents behaved. Moist air from the coasts rarely reached the center. The central regions remained dry for most of the year. This dryness created vast deserts larger than any today. The edges of Pangea, near the seas, were more balanced. These areas had rainfall, rivers, and plant growth. The world was warm almost everywhere. Even the poles were free of permanent ice. The carbon dioxide in the air was much higher than modern levels. It trapped heat and created a greenhouse climate. The global temperature was steady but high. Nights were cooler, yet the air held moisture in the coastal zones. In the deserts, nights turned cold quickly. This range of temperature shaped how animals survived. Species evolved to handle both heat and cold. The reptiles, for example, had thick skin and scales that protected them from losing moisture. Amphibians lived near water sources. Insects adapted to harsh sunlight by developing strong shells. Forests grew near lakes and along the coasts. They were full of tall conifers and seed ferns. The ground was soft, covered in decaying plant matter. Rivers carried minerals into the soil, helping new plants grow. The cycle of life was steady. Trees fell, decomposed, and returned nutrients to the earth. Insects fed on the remains, and smaller creatures fed on the insects. You would have heard a constant background of life, the quiet rustle of movement in the leaves, the call of early reptiles, the hum of large dragonflies flying through warm air. The interior of Pangea was different. It was almost silent. Wind blew across open plains of sand. Few plants grew there. Some hardy shrubs survived near rare oases. Fossil evidence shows that these deserts covered thousands of kilometers. Only small animals could endure such conditions. Their bones tell a story of survival in isolation. The contrast between the wet coasts and the dry center created distinct ecosystems. Species living in one area often never reached the other. The continent's size was both an opportunity and a limit. Rain patterns were unpredictable. The coasts had tropical storms that flooded the land for days. Then came long dry periods. Rivers swelled, then shrank into thin streams. In some places, temporary lakes formed after heavy rains, then vanished under the sun. This unstable environment shaped evolution. Animals that could move long distances survived. Many reptiles laid eggs on dry land, which gave them an advantage. Amphibians, which needed water for breeding, remained close to lakes and rivers. Over millions of years, these differences led to new species. The sea surrounding Pangea was alive with marine creatures. Giant fish swam near the coasts. Ammonites floated through the water, their spiral shells glinting in sunlight that reached shallow depths. Sharks ruled the deeper zones. Reptiles such as ichthyosaurs hunted smaller prey near the surface. Coral reefs struggled to survive because the warm water often lacked oxygen. Yet some reef systems did exist, built by sponges and microorganisms instead of coral. The ocean floor was rich in sediment, where early life forms thrived unseen. The coasts of Pangea were full of life transitions. Marine reptiles came ashore to rest and breed. Amphibians lived in marshy zones between land and sea. Fossils show footprints in ancient mud, preserved through ages. These traces record the movement of creatures between two worlds. The coastline shifted constantly as tectonic forces lifted or lowered land. New bays appeared. Old lakes dried out. The landscape was always changing, slowly but without pause. The air over Pangea carried a distinct smell. It was heavy with dust in dry regions and filled with moisture near the coasts. Lightning storms brought the scent of ozone. After rain, the ground released steam and earthy odors. Volcanoes added the smell of sulfur to the air. The mix was intense but natural. Breathing in that world meant breathing in the raw elements of an evolving planet. Volcanic activity played a large role in shaping the climate. Eruptions released ash and gases that affected sunlight and temperature. Short-term cooling sometimes followed large eruptions, but the long-term trend stayed warm. Lava fields stretched for miles, creating new land. Over time, plants grew again on the cooled rock. The cycle of destruction and renewal continued endlessly. The Earth was alive, not only through the creatures on its surface, but through the forces beneath it. The distribution of animals across Pangea gives scientists important clues. Fossils of the same species appear in far-apart modern continents. For example, fossils of the reptile Lystrosaurus have been found in both Africa and Antarctica. This proves those lands were once joined. The plant Glossopteris grew across wide regions of the supercontinent. Its fossilized leaves show how vegetation spread freely before the breakup. The same goes for early amphibians and insects. Their fossils link the distant lands we know today. Life in Pangea was both abundant and limited. The planet supported wide diversity, but each environment had its challenges. Coastal zones supported lush forests and swamps. Inland deserts tested every form of life. Ocean life was rich near shorelines, but sparse in deep waters. The entire planet operated as one connected system. A change in one region could affect the rest. Volcanic eruptions could darken skies over the entire world. Shifts in ocean currents could alter rainfall thousands of kilometers away. The rhythm of life followed the seasons. Pangea tilted on its axis, so parts of it had long summers and winters. The equatorial zone stayed warm all year. In these areas, forests grew thick and animals stayed active. Farther from the equator, dry and wet seasons alternated. During the wet months, plants grew rapidly. During the dry months, many areas turned brown and quiet. The pattern repeated year after year, generation after generation. Scientists know about these conditions from the rock layers left behind. Sediments formed from ancient rivers show alternating wet and dry periods. Fossil pollen and spores tell us what plants grew where. Carbon isotopes reveal how much carbon dioxide was in the air. The evidence paints a clear picture of a warm planet dominated by one vast landmass and one endless ocean. The ecosystems of Pangea were the foundation for future evolution. From these early environments came the ancestors of modern reptiles, mammals, and birds. The survival challenges of the dry interior made animals stronger and more adaptable. The forests along the coasts protected fragile species that would later evolve into new forms. Every corner of Pangea held a piece of the future. The balance between life and environment was direct, simple, and raw. If you stood on the land during that era, you would see endless variety. You might look across dunes of orange sand, then walk days to reach a river lined with green trees. You would feel the warmth of the sun, hear insects buzzing, and see slow-moving creatures resting in the shade. Each day passed quietly, yet every moment shaped the history of life. The stillness of that time was full of unseen motion, air shifting, water flowing, life changing, continents moving. Over millions of years, the same heat that kept Pangea alive would start to break it apart. Deep below, pressure built up as magma pushed against the crust. Cracks formed slowly. The first signs of separation began near the coasts. The planet was preparing for its next transformation. But for now, Pangea stood strong, its vast deserts, warm forests, and ancient seas holding the story of a connected world. One land, one ocean, one living system moving through deep time. The geography of Pangea was simple in shape but complex in structure. One large continent stretched across much of the planet's surface. It extended from the northern polar region to the southern. The equator crossed through its middle, dividing it into warm tropical zones and temperate regions toward the poles. Surrounding this vast land was one ocean, the Panthalassa. There were also smaller seas between parts of the landmass, such as the Tethys Sea, which lay between the northern and southern sections. The surface of Pangea was not flat. Mountain ranges, plateaus, plains, and deep basins covered it. Many mountains formed where tectonic plates collided as the supercontinent came together. These areas were active, with frequent earthquakes and volcanic eruptions. Some mountain chains were tall and wide, stretching for thousands of kilometers. Rivers flowed down from them, carving deep valleys that carried sediment to the lower lands. Over time, these rivers created fertile zones where plants grew densely. The deserts of Pangea were massive. The center of the continent was dry because it was too far from the ocean. Moist air could not travel that far inland. Scientists believe this desert, known as the Central Pangean Desert, may have been one of the largest in Earth's history. The soil was thin, and there was little plant cover to hold it in place. Winds carried sand and dust across great distances. Dunes moved slowly over the land, shaped by constant wind. When rain did fall, it created temporary rivers that disappeared quickly. Toward the coasts, the environment changed. Forests appeared, lakes formed, and the soil grew thicker. In tropical zones, rainforests developed. In cooler areas, conifer forests covered hills and valleys. Swamps filled lowlands near the sea. The land rose and fell gently in many places, creating complex drainage systems. Water collected in basins, forming large inland lakes. Some of these lakes lasted for millions of years before drying out or connecting to the sea through erosion. The climate of Pangea was influenced by its size. Because it covered so much of Earth's surface, the ocean had less control over its temperature. On modern Earth, oceans absorb and release heat, keeping climates moderate. On Pangea, that balance did not exist. Summers were extremely hot in the interior, while winters could be cold. The temperature difference between coast and center was huge. The interior could have reached 45 degrees Celsius in summer and dropped below freezing in winter. The coast stayed milder because of the ocean's influence. Weather systems on Pangea moved slowly. With one large landmass and one large ocean, the global wind pattern was different. Air rose over warm regions near the equator and sank near the poles, creating a single circulation system that stretched over thousands of kilometers. This circulation affected rainfall. Equatorial regions received heavy rain, while the interiors and higher latitudes remained dry. Monsoon-like patterns may have occurred in some areas, bringing seasonal rains followed by months of drought. Storms were common near the coasts. The warm air from the land met cooler air from the ocean, creating strong winds and heavy rainfall. Lightning was frequent, especially in tropical zones. Rainwater ran down mountain slopes and collected in valleys, forming rivers that fed coastal plains. Flooding occurred often during wet seasons. These cycles shaped the soil and helped plant life spread. Each storm changed the landscape a little more, carrying sediment from highlands to lowlands. Ocean currents were simpler than today, but stronger. The single ocean around Pangea allowed water to move in large circular patterns. These currents carried heat from the equator toward the poles and brought cooler water back toward the equator. The lack of continental barriers meant these flows were massive and steady. They played a role in keeping the global climate stable, even though the land experienced wide temperature swings. Marine life depended on these currents for nutrients. The movement of warm and cold water determined where plankton, fish, and larger predators gathered. The polar regions of Pangea were not frozen. Fossil evidence shows forests existed there, meaning temperatures stayed above freezing for most of the year. During parts of the year, the poles received continuous sunlight, while during others they stayed in darkness, just like today. The difference was that there were no ice caps to reflect sunlight, so the Earth absorbed more heat. This helped maintain a warm global average temperature. Even the coldest regions of Pangea supported vegetation and animal life. Mountain chains on Pangea influenced both weather and biodiversity. The central mountains acted as barriers that blocked moist air from moving inland. This increased desert conditions in the center. On the windward side of mountains, rainfall was heavy. On the leeward side, the land stayed dry. These rain shadows shaped local climates and separated ecosystems. Some valleys had lush forests, while others remained barren. Over time, these patterns encouraged the development of unique species adapted to their surroundings. The volcanic activity of Pangea was constant. Large eruptions released gases such as carbon dioxide, sulfur dioxide, and methane. These gases affected the climate by trapping heat or reflecting sunlight. Short cooling periods followed major eruptions, but over millions of years, volcanic emissions added more greenhouse gases to the atmosphere. This kept the planet warm. Ash from eruptions settled on the ground, enriching the soil with minerals. In some regions, this helped forests regrow faster. Earthquakes were another common feature of life on Pangea. The supercontinent sat on several tectonic plates that were always moving. As the plates pressed and shifted, the ground shook. Some regions experienced strong quakes that changed the shape of the land. These movements also created cracks and rifts that allowed magma to rise. Eventually, these cracks would grow into rift valleys that played a role in breaking Pangea apart millions of years later. Rainfall data from ancient rock layers shows that Pangea's weather followed long cycles. Wet and dry periods lasted thousands of years. These cycles were linked to changes in Earth's orbit and tilt. When the planet tilted slightly more, some regions received stronger seasons. When the tilt was less, the climate became more stable. These natural cycles had a strong impact on life. Animals migrated to follow water and food. Plants grew in pulses, spreading widely during wet phases and shrinking back during dry ones. Pangea's geography also influenced how sunlight reached the surface. Large inland areas experienced extreme heat during the day and rapid cooling at night. The thin atmosphere over deserts caused sharp temperature swings. In forests and coastal areas, humidity moderated these changes. The sunlight itself was intense, especially near the equator. The thick vegetation there absorbed large amounts of energy, helping regulate local climates. Dust storms were a part of Pangea's weather too. With few plants to hold the soil, Wind lifted fine particles and carried them across the land. These storms could last for days. They spread minerals from dry areas into fertile zones, feeding ecosystems. Layers of ancient dust preserved in rock tell scientists how often these storms occurred. They show that Pangea's interior was constantly shifting under the influence of wind and weather. Lightning and fire were part of the environment as well. Dry vegetation often caught fire after lightning strikes. These natural fires cleared old plants and made room for new growth. They also released carbon into the air. Fire became an important factor in the natural cycle of forests. Evidence of ancient charcoal and rocks shows that fires were common even hundreds of millions of years ago. The vast scale of Pangea meant that no two regions were exactly alike. Some areas near the equator were always humid and green. Others, only a few hundred kilometers away, were dry and harsh. The distance between coast and center made climate zones wide and distinct. The balance between heat, moisture, and elevation shaped everything that lived there. Each region followed its own rhythm within the larger system of the planet. Scientists continue to study the geography and weather systems of Pangea through rock samples and fossil records. Patterns in sediment, mineral content, and fossilized plants reveal how temperature and rainfall changed over time. Magnetic minerals and rocks show the position of the poles and help map the ancient landmass. These studies confirm that Pangea was dynamic. It was always moving, always changing. The same processes that formed mountains and deserts on Pangea still work on Earth today, slowly reshaping continents and climates. The world of Pangea was one of balance and force. The land was vast, the ocean endless, the air heavy with heat and dust. Winds shaped the deserts, rain carved valleys, and volcanoes built mountains. Every feature of that world came from movement, of air, of water, of rock. These patterns set the stage for everything that followed, from the rise of dinosaurs to the formation of new continents. The geography and weather of Pangea were not only features of a distant past, but the blueprint of the Earth we know. During the age of Pangea, life on Earth had already taken firm control of both land and sea. The planet was home to an enormous variety of creatures, though none looked like the animals you know today. The world was ruled by reptiles, amphibians, and insects. Mammals were small and rare. Birds did not yet exist. The oceans held strange and powerful predators. Every form of life was adapted to a planet still shaping itself. Reptiles were the dominant group on land. They had thick skin, strong limbs, and tough eggs that survived dry conditions. These features allowed them to live far from water. Some species reached impressive sizes, while others stayed small and fast. One of the earliest large reptiles was Dimetrodon, a creature with a large sail on its back made of bone and skin. It lived before the true dinosaurs, but set the pattern for them. Fossil evidence shows that Dimetrodon hunted smaller reptiles and amphibians. It lived near rivers and lakes, where prey was easy to find as time passed. New reptile species spread across Pangea. They filled every environment: forests, deserts, coasts, and swamps. Some walked on four legs, some on two. Their teeth and jaws show what they ate. Sharp, pointed teeth belonged to hunters. Flat, ridged teeth belonged to plant eaters. These early reptiles were the ancestors of dinosaurs, crocodiles, and even modern birds. The dry climate helped them thrive because they needed little water. Amphibians were still common but less dominant than before. They depended on water for breeding. Many species lived in swamps and rivers along the coasts. Some reached sizes over 2 meters long. Their thick, smooth skin allowed them to breathe through it. Fossils show strong bones and broad skulls suited for catching fish. When the land dried up, they hid in mud or stayed near shaded areas. Amphibians were an important part of the food chain. They fed on insects and smaller creatures, while reptiles fed on them. Insects were everywhere. They had evolved into diverse shapes and sizes. Dragonflies had wingspans as wide as your arm. Beetles, cockroaches, and primitive ants filled the forests. Termites built small colonies in decaying wood. These insects helped recycle the planet's nutrients. They broke down fallen plants and dead animals. Without them, the forests of Pangea would have been buried under layers of decay. Their buzzing, crawling, and feeding kept the system balanced. The air over Pangea was thick with insect life. Large dragonflies hunted smaller flying insects. Their sharp eyes and quick flight made them skilled predators. Butterflies and bees did not exist yet because flowering plants had not evolved. Instead, insects fed on ferns, mosses, and spores. Some lived inside tree bark. Others stayed in the soil. The ecosystem was simple but efficient. Every role was filled. The oceans of Pangea were full of life. Reptiles had moved into the water and become skilled swimmers. One famous marine reptile was the ichthyosaur. It looked similar to a modern dolphin, but was not a mammal. It had a long snout filled with sharp teeth, a powerful tail, and large eyes for seeing in deep water. It hunted fish and squid-like creatures. Fossils show females giving birth to live young, an adaptation that helped them survive far from land. Another large marine reptile was the plesiosaur. It had a broad body, long neck, and paddle-like limbs. It swam slowly near the surface, catching fish with quick strikes of its head. The oceans were also home to nothosaurs and mosasaurus, both powerful predators that ruled the coasts. Some species stayed near shallow waters, while others ventured deep into the Panthalassic Ocean. These creatures were among the first to show how reptiles adapted completely to marine life. Fish were abundant and diverse. Sharks existed in many forms, from small reef hunters to massive open-water species. Cartilaginous skeletons gave them flexibility and speed. Bony fish evolved new shapes and sizes, filling every niche in the sea. Some fed on plankton. Others hunted in schools, striking quickly at prey. Fossil beds show entire layers of fish preserved together, trapped during sudden changes in water temperature or oxygen. Ammonites were one of the most common sea creatures. Their coiled shells are found in rocks all over the world today. They floated in the water, using small tentacles to catch food. Their shells protected them from predators, but also recorded chemical details of ancient oceans. By studying ammonite fossils, scientists learn about temperature, salinity, and even the chemistry of seawater during Pangea's age. Coral reefs were less widespread than in modern times because warm water held less oxygen. But other reef builders took their place. Sponges, algae, and microorganisms created hard surfaces where small animals could live. These reefs supported a web of life: crustaceans, mollusks, and early cephalopods. Crabs and lobsters moved slowly across the seafloor. Starfish and sea urchins clung to rocks. Each level of the ocean was alive with motion. On land, smaller creatures filled the gaps between large reptiles. Early mammals existed but were small, fur-covered, and nocturnal. They hid from reptiles during the day and searched for insects at night. Their fossils show teeth adapted for chewing plants and meat. These mammals were the ancestors of all modern mammals, including humans. Their survival during the age of reptiles depended on their ability to hide, adapt, and reproduce quickly. In the forests, reptiles evolved into new forms. Some grew long necks to reach higher vegetation. Others developed armor-like scales for protection. Early archosaurs, a group that would later give rise to dinosaurs and crocodiles, became dominant. They were fast, strong, and smart hunters. Their footprints appear in fossilized mud across different parts of Pangea. These tracks show how widely they spread. The ecosystem of Pangea was balanced but fragile. Every creature depended on another. When climates shifted, entire groups moved or disappeared. Droughts in the interior deserts forced animals to migrate toward the coasts. Floods changed the shape of rivers and destroyed habitats. Volcanoes released gases that changed air composition. Yet life adapted each time. Evolution was constant, slow, and steady. The air was filled with the sounds of life. Insects buzzed, reptiles hissed, amphibians croaked near water, and the sea roared against rocky shores. Nights were quiet except for the low calls of distant creatures. Stars filled the sky, untouched by artificial light. The planet was pure, natural, and alive with its own rhythm. Plant life supported all of this. Giant ferns, seed ferns, and conifers provided food and shelter. Insects fed on their leaves, amphibians hid in their shade, and reptiles rested beneath them. Forest floors were damp and rich with decomposing matter. Each layer of the ecosystem fed another. The balance between plant and animal life shaped the planet's stability. Fossil evidence shows that life during Pangea's age experienced several extinctions and recoveries. some caused by climate shifts, others by volcanic eruptions. Yet every extinction was followed by renewal. New species appeared, better suited to the changing conditions. This continuous cycle kept life evolving toward more complex forms. By the end of Pangea's age, early dinosaurs were spreading, insects were thriving, and the oceans were full of predators. The creatures of Pangea lived in a world without borders. They moved freely across the supercontinent, from what is now Africa to South America to Asia. This freedom allowed them to spread widely and evolve together. The similarities in fossils across these modern lands prove that life was once connected. When Pangea began to split, these same species became separated, evolving differently on each new continent. The age of Pangea was a turning point for life on Earth. It created challenges that shaped the future of evolution. Dry climates forced adaptation. Large oceans encouraged marine diversity. Volcanoes changed air and temperature, driving new survival strategies. Every reptile, insect, and fish of that time played a role in shaping the planet you live on today. When you think of that ancient world, picture a planet full of life, energy, and movement. A world where giant reptiles walked through hot plains, dragonflies hovered above still waters, and deep oceans carried silent hunters. Pangea was alive in every direction, from the smallest insect to the largest sea creature. It was a time of creation, struggle, and endless change, the heartbeat of Earth. Deep beneath the ancient world of Pangea, the Earth was alive. It moved, it breathed, and it never rested. What looked calm on the surface was only a thin shell above enormous power. The planet's crust was constantly shifting, cracking, and reforming. These movements gave rise to volcanoes and earthquakes. They shaped the mountains, split the oceans, and carved the lands where life would rise and fall. Pangea was not still. It floated on massive plates of rock called tectonic plates. These plates moved slowly, driven by the heat inside the Earth. That heat came from the planet's core, a place so hot that rock melted into glowing magma. This molten rock rose upward, looking for weak spots in the crust. When it found them, volcanoes were born. Each eruption changed the world's surface, adding new land or destroying old ground. Imagine standing in the middle of ancient Pangea. The horizon glows red from the light of distant volcanoes. The air smells of smoke and minerals. The ground trembles under your feet. Rivers of molten rock flow like fire. The sound is low and endless, a deep rumble that never fades. This was the heartbeat of Earth, the sound of a planet still being formed. Volcanoes were common along the edges of tectonic plates. There, plates collided, pulled apart, or slid against each other. When plates pushed together, one plate slid beneath the other, melting into magma. That magma rose again, breaking through the surface as fire and ash. Mountains formed at these boundaries, growing taller with every eruption. When plates pulled apart, cracks opened, and magma filled the space. This created new crust, new land, straight from the heart of the planet. The supercontinent's shape was influenced by these forces. When Pangea first formed, continents collided with immense energy. The impact folded the Earth's crust into towering mountain ranges. Some of these mountains were higher than the modern Himalayas. Over millions of years, wind and rain wore them down. Sediments from those peaks filled the valleys and plains. Even today, parts of those ancient mountain routes remain visible in Africa, North America, and Europe. Volcanoes did more than shape the land. They shaped the air. Each eruption released gases like carbon dioxide, sulfur dioxide, and water vapor. These gases entered the atmosphere and changed the planet's climate. Some eruptions cooled the world by blocking sunlight with ash. Others warmed it by adding greenhouse gases. The balance between these effects decided whether deserts expanded or forests grew. During the time of Pangea, massive volcanic events known as large igneous provinces occurred. These were not single volcanoes, but vast regions of eruptions lasting millions of years. One of the most famous was the Siberian Traps, a gigantic volcanic area that covered what is now Siberia. Lava spread over millions of square kilometers, releasing enormous amounts of gas into the atmosphere. Scientists believe this event played a major role in the Permian extinction, one of the deadliest moments in Earth's history. The Siberian Traps erupted for hundreds of thousands of years. Lava poured over forests, burned soil, and filled the air with toxic fumes. Oceans absorbed the gases, becoming acidic. Many species could not survive. More than 90% of marine life and 70% of land species disappeared. Yet from this destruction, new forms of life emerged. Earth recovered slowly, reshaping its ecosystems. Volcanoes had destroyed, but they had also prepared the planet for renewal. Earthquakes were another sign of Pangea's restless energy. When plates moved, friction built up along their boundaries. The stress grew until the rocks suddenly broke, releasing shock waves that traveled through the crust. The ground shifted, mountains cracked, and rivers changed course. Some earthquakes were small tremors. Others were massive, reshaping entire landscapes in moments. In the interior of Pangea, earthquakes were less frequent but still possible. The giant continent pressed down on the planet's crust unevenly. This pressure caused cracks deep underground. When those cracks shifted, the ground moved. Over time, the crust lifted and sank in different areas, forming basins and plateaus. Some regions rose slowly, creating highlands. Others sank, becoming ancient lake beds or shallow seas. These movements were slow on a human timescale, but powerful over millions of years. Each motion, each vibration, helped sculpt the face of the planet. Even small changes added up. The land you stand on today, whether mountain or plain, exists because of these ancient shifts. The forces that shaped Pangea never stopped. They continue to move the continents even now, inch by inch, year by year. Inside the Earth, heat and pressure were constant. The outer core, made of liquid metal, moved in swirling patterns. These movements created Earth's magnetic field, a shield that protected the planet from solar radiation. Without this magnetic field, life might never have survived. Volcanoes and earthquakes, though destructive, were signs that the planet was alive and working to maintain that balance. The link between volcanoes, climate, and life was deep. When eruptions cooled the planet, some species perished, but others adapted. When gases warmed the air, new environments formed. Rain patterns shifted. Deserts expanded or shrank. Forests grew in new areas. Every volcanic pulse changed the path of evolution. Life responded to every shift with new strategies for survival. In the oceans, undersea volcanoes played their part too. Along the ridges where plates pulled apart, magma rose to form new ocean floor. Hydrothermal vents appeared, cracks where superheated water mixed with minerals. These vents created small ecosystems deep below the surface. Bacteria and strange creatures lived there, feeding on chemicals instead of sunlight. Even in darkness, life found a way. These ancient ocean vents may have been among the first homes for life on Earth. On land, the effects of volcanoes could be both devastating and creative. Lava flows buried forests, but also created rich soil after they cooled. That soil supported new plant life, denser and stronger than before. After destruction came growth. The pattern was endless: eruption, ruin, renewal. Earth's natural rhythm was a cycle of death and rebirth. Lightning storms often followed large eruptions. Ash and gas in the sky created static electricity. The air filled with thunder and flashes of light. To ancient creatures, these storms must have seemed like the anger of the planet itself. Yet every bolt of lightning carried nitrogen to the ground, feeding the soil. Even destruction carried hidden benefits. Over millions of years, the same forces that built Pangea also tore it apart. As heat rose from the mantle, new cracks formed in the crust. Magma pushed upward, separating the plates. Slowly, the supercontinent began to stretch. What was once one landmass began to split into pieces. These were the first signs of the continents we know today: Africa, South America, North America, and Eurasia. Volcanoes marked the places where this splitting began. Lava filled the cracks and hardened, forming new ocean basins. Earthquakes signaled each movement. It was not sudden. It was slow, steady, unstoppable. Over tens of millions of years, Pangea broke apart completely. But the memory of its unity remains written in rocks and fossils scattered across the globe. Every mountain chain, every valley, every coastline carries the mark of that ancient time. The Andes, the Appalachians, the Atlas Mountains, all trace their roots back to Pangea's collisions and separations. Even the Atlantic Ocean began as a small crack within that mighty continent. Volcanoes and earthquakes were the tools through which the planet sculpted its masterpiece. When you imagine Pangea, see not just land and sea, but motion and energy. Picture continents drifting, mountains rising, volcanoes glowing, and oceans boiling. Hear the deep rumble beneath the ground. Feel the tremor of shifting rock. The earth was alive, loud, powerful, and endlessly creative. Its surface changed like breathing, always expanding, contracting, and transforming. And though Pangea itself vanished long ago, the same heartbeat still echoes today. Every earthquake, every eruption, every mountain that grows or falls is part of that same ancient rhythm. The forces that built Pangea still shape the world you live in. The planet never sleeps. The world of Pangea was a place of extremes. The land was huge, stretching from one pole to the other. The ocean that surrounded it was vast and deep. The air above it was thick with heat and gas. The balance between land, sea, and sky decided how life survived. Every breeze, every drop of rain, every drought was shaped by the size and shape of the supercontinent. When so much land was gathered into one mass, the weather changed in ways no smaller continent could experience. Moisture from the sea could not reach the interior easily. Winds carried water vapor inland, but it fell as rain long before reaching the center. This left the heart of Pangea dry. The deserts there stretched for thousands of kilometers. Sand dunes rose and shifted under the relentless sun. The air shimmered with heat during the day and cooled sharply at night. Life there was rare and tough. Closer to the coasts, the story was different. There, warm air met cooler ocean breezes. Clouds formed and rain fell regularly. Forests thrived along rivers and deltas. These coastal regions were lush and green. They supported ferns, cycads, and tall conifers. The difference between the wet coasts and the dry interior was sharp, creating strong climate zones. The Earth's atmosphere was richer in carbon dioxide than it is today. This made the greenhouse effect strong. Average global temperatures were high, and the poles had no permanent ice caps. Even areas near the poles had forests and flowing rivers. The entire planet was warm, humid in some places, arid in others. The air was dense and full of life-giving gases, feeding the rapid growth of plants. Scientists estimate that carbon dioxide levels during the late Paleozoic and early Mesozoic eras were between 3 and 10 times higher than modern levels. This created a stable but hot climate. The heat was constant, and seasonal changes were slow. Without polar ice, sea levels were higher. The atmosphere circulated in large, predictable patterns, forming steady winds that moved from the equator toward the poles. Those winds carried dust from the deserts into the oceans. The dust contained minerals that fed plankton, linking land and sea. Even far from the coast, the ocean depended on what the land released. Each grain of dust that settled in the water helped build the food chain. This process supported the marine life that would later evolve into new forms in the equatorial region of Pangea. Intense heat created heavy rainfall at certain times of the year. These were the early monsoons. When the land heated faster than the sea, air rose over the continent, pulling moist air inland. Rain poured down for weeks, flooding rivers and lakes. Then, as the land cooled, the winds reversed, carrying dry air back toward the ocean. The rhythm of wet and dry seasons became the heartbeat of equatorial Pangea. During the wet season, plants grew fast. Rivers overflowed, and swamps spread wide. Insects swarmed. Amphibians bred in shallow pools. Reptiles basked along the edges of muddy water. Then, when the dry season returned, the land cracked. Water evaporated. Many animals migrated or burrowed underground to survive. The cycle of abundance and scarcity repeated endlessly. The monsoon patterns of Pangea were stronger than those of today. The continent's size created greater differences between land and sea temperatures. The seasonal shifts in wind were more dramatic. These winds shaped erosion, carried nutrients, and influenced where life could thrive. The same winds that brought rain could also bring dust storms. For weeks, fine sand would blow across open plains, burying plants and reshaping the ground. The temperature difference between the equator and the poles was smaller than today. Heat spread more evenly across the planet. Tropical conditions extended farther north and south. This allowed forests to grow in regions that would now be considered temperate. It also meant that the climate was stable over long periods. Life adapted to consistency rather than change. Evolution during this time moved slowly, following the rhythm of the land. Still, there were moments of disruption. Volcanic eruptions and tectonic shifts could change the climate suddenly. Ash clouds blocked sunlight, lowering global temperatures for years. Acid rain followed large eruptions, altering soil chemistry. Some regions became too harsh for existing plants. Others saw new growth as species adapted to the new balance. Climate and life were linked in an unbroken exchange, each shaping the other. In the dry interior of Pangea, the air was often filled with fine dust. Storms lifted it high into the sky, where it traveled vast distances. When it settled again, it covered plants and left layers of sediment that hardened into rock. These layers still tell scientists about the ancient atmosphere. Trapped within them are grains of pollen, spores, and tiny air bubbles. They are time capsules from a world that no longer exists.